Assalamu alaikum. Hello everyone. In this lesson, I'm going to show you how to divide numbers in an easier way because many students struggle with that. So let's build the basics so it becomes a second nature for you. Remember that in the classroom or when you're doing your homework or when you're sitting in an exam, you have to show all the working of the solution of the problem, whatever you do, so that the examiner can see your thought process, can see how you have solved a particular problem, what steps you took, which direction you took, etc., etc. And that is what you're graded for, not just the final answer. It is quite possible in exams that the final answer you get is wrong, but the working you show, you get good amount of marks on that. So that is why you need to show all the working, and you show it neatly and clearly. By neatly and clearly, I don't mean that you start making, start doing makeup of your worksheet by putting on red and green and blue and black and all those sorts of highlighters and colors and whatnot, because that indicates a distracted mind. That shows that you're more focused on beautifying it than solving the problem. And it not only shows, it is actually true that your mind is busy beautifying it and not actually solving the problem. So stick to one color, whatever the color of your pen or your pencil, and just stick to it and just solve the problem, and that's it. If you solve it clearly and neatly, the examiner will see it. You don't need to use highlighters and whatnot. Right, let's start. So let's say we have a question, a very simple question, which says 8 divided by 2. It is read as 8 divided by 2. And you must develop a habit of saying this sentence in your mind. I'll write it a few times, but then you get the idea and you always do that. And whatever you do in the working, you try to write it in writing as well, to help the examiner or to help the evaluator that what did you do, why did you take a certain step, why did you do something in a certain way. You have to explain it, right? So 8 divided by 2, you write it like this. There's a division symbol which goes like this. Traditionally it used to be something like this, right? But now it is just shortened to something like this. Remember, this symbol, division symbol, is different than this symbol. This is a different symbol. Okay, it has a different meaning. So I'll not go into that right now. All right. So when 8 is being divided by 2, you write 8 inside because that's being divided, and you write the divisor, which is 2. You write it outside. Right, and then you start checking. What do you check? You see, these are both of them are single digit numbers. So you check if this number, it should be at least equal to or greater than the divisor. If that is the case, then this division is possible without going into decimal system, the decimal points. In our case, it is true, 8 is greater than 2. So this division is possible. And now we need to find out what multiple in 2's table gives us 8. So 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. So we write 4 here, the multiplier, 2 4s are 8. And we write 8 right beneath this. And we do a subtraction, and we do 8 minus 8 is 0. Normally we write or put a cross here, and there is a very valid reason for that. Anyhow, either a 0 or across here would basically means 0. So now this means this is always what is called remainder, right? This is what was left, and you can say in our case nothing was left, and this is the answer. Its technical name is quotient, Q-U-O-T-I-E-N-T, quotient. So it's also the answer most of the time. And this one, technically it's known as dividend. And this one is known as the divisor, right? So this actually, this is very good that we did this. This is the anatomy of a division operation, right? So we can actually put this here to keep it as a reference, right? And we can make a box around it maybe. Oops, excuse me. Right, anyway, so this is what it looks like. So in this case, remainder is nothing, or we could write for our understanding, remainder is 0. When the remainder of a division operation is 0, it is called successful division or complete division. Right. So let's solve another question, right? So we have 9 divided by, divided by 3. So we write that, just for the sake of understanding, 9 divided by 3, and we do it in a very simple way. We do it like this: we put 9 inside, we put 3 outside, and then we compare. Is this number, the dividend, is it greater than or at least equal to the divisor, which is 3? And that is true. 9 is greater than 3. So now we need to check in 3's table what multiplier would give us the number which is closest to this number. Closest would also mean closest and at least less than, not more than 9. So in 3's table, the number closest to 9 is, let's see, 3 1s are 3, 3 2s are 6, 3 3s are 9, which is true. So we actually got the actual number. So we say 3 times is 9, and we subtract them, and we got 9 minus 9 is 0, or we just say cross, which means nothing is left, and this means 3 is the answer. In our case, 4 was the answer here, right? So I have to write 4. You don't need to circle the answer, it's just I'm highlighting it here. Right, so let me solve another problem in which there won't be a successful division. I just want to show you what happens when you do that. Alright, so let's solve another problem. Let's say 8 divided by 3, right? This is just an example. So it says 8 divided by 3. So we do that. We write 8 inside and we write 3 outside. And now we check if this number 8 is larger than or at least equal to 3, which is true. It is greater than 3. So first check is passed. Now we check in 3's table, which is the divisor, what multiplier give us the number closest to 8? Either closest to, either equal to, or less than, never more than the number which is here. So we check. 3 1s are 3, 3 2s are 6, 3 3s are 9. So there are two numbers closest to 8. 3 2s are 6 and 3 3s are 9. But 9 is bigger than 8. We cannot subtract 9 from 8. So we have to use the number before that, which is 3 2s are 6. So we always go for the lesser number if it is not an equivalent number. So 3 2 times is 6. We draw a line here, we do a subtract, and we get 8 minus 6 is 2. And this is our remainder. We did not have a successful division, which means we did not have 0 as a remainder. We actually got 2 as remainder. So this is just an example in which this is how it looks like. But in the early grades, you won't get questions like this. This is just an example. Right, let's solve a double-digit question. So a question is let's do 12 divided by 3. Right, so we write 12 divided by 3. Let's solve that. So how do we do that? We write 12 inside and we write 3 outside, and we start with the first digit, which is just 1, and we check if 1 is equal to or greater than the divisor, which is 3, and that is not true. 1 is not equal to 3, 1 is not greater than 3. That means it cannot be divided by 3. It doesn't come in its it doesn't appear in its it's not its multiple. It doesn't appear in its table, mathematical table. So what do we do? The correct way to, or a formal way to do it, is that once the number is insufficient, as this one here is, we join the next number, the next digit, one digit, with this number and consider it a new number to be divided by the divisor, which is 3. And when we do that, when we join this together, and this 9 is not required, this is just a visual representation for you for the moment. When the number is joined, then you do put a 0, always a 0 on top, and then you join the number. Now this number has become 12, and I'm going to remove this line. This number has become 12. Now we check what multiplier will give us 12 in 3's table. 3 1s are 3, 3 2s are 6, 3 3s are 9, and 3 4s are 12. So we write 4 here, 3 4s are 12. Then we do a subtraction, and 12 minus 12 directly is 0, or nothing left. Very good. So we have a successful division, and here is our answer. But let me write that here first. This is 0 4. Is it 40 or 4? So this leading 0 in any number, the leading 0 is always insignificant. We don't need to write it. So 0 4 is technically just 4. and that is our answer, right? Okay, this also means that in the division here, in the first step, when we said, well, 1 is smaller than 3, we need to join another number, then the first time you bring up this 0, the very first step, in the very first step, before you write any other number, when you need to join two numbers together, in the very first step, you don't need to write this 0 because it's going to be removed anyway, right? But for completion's sake, I have shown it here. Right. Let's solve more questions. And I'm going slow because this is, of course, a lecture, and I want you to understand how these divisions are done. So I'm going to show you another division. Let's say 24 divided by 2, right? So this is read as 24 divided by 2, which means 24 will come inside of the symbol and 2 will be outside. Now we check the first digit because this is a single digit outside. The divisor is single digit, so we check single digit here and we see if this 2 is either greater than or equal to the divisor, which is 2, and that is true. 2 is at least equal to 2, so that means we can divide it by doing a multiplication. 2 ones are 2. Now remember, this we have now come into this double digit division, and this is very special. Now sometimes, not regularly, if you're just given a subtraction question, remember, if you are given a subtraction question, say 24 minus 2, what you will do is you will write it like this, 24, and you align it on the right side, and you say minus, and you say 2. Then you say 24 is 4 minus 2 here is 2, and then this 2 just simply falls down, and the answer is 22. This is only and only if you have a subtraction question like this. Here, what we have done is we just took the first digit, and we are just handling or just managing the first digit. We have completely ignored this number here at the moment. Completely ignored it. So this means when we do this multiplication, 2 1 times is 2, we subtract only these two numbers, right? Let me draw that here. We subtract, let me just highlight it here, we subtract just this number, and we completely ignore the other numbers. So here, this is a special way of subtraction. We are just subtracting 2 minus 2. You must remember that. Don't subtract 24. Don't subtract 2 from 24 here. Subtract only 2 from the digit 2 up, which is present here. So 2 minus 2 is 0. We put a cross here. Okay, and then we go for the next digit, which is 4, which is still remaining to be divided, to be processed. So since 4 is left, then this means that it is 4's turn to come here, to fall below this line, the line which we drew here. So now 4 will come here. Now before I perform the next step, I want to highlight that why I put a cross here, because in the beginning I said this is a cross and not 0. It is meant to be 0. It is considered 0, but it's we put a cross here because if it was 0, which is perfectly alright, there is high chance for some students to confuse it as 40. It is not 40, it is 04, which is just 4. But there is high chance that somebody would get confused. So that is why, to make sure that this remainder doesn't get mixed up with the other numbers, we actually use a cross. That way, visually, we can just ignore this part, right? Let me highlight that. Visually, we can then just simply ignore this part, x, and we just manage the next number, which is 4. Right. So now we come to the next point, which is 4. And what do we do with this 4? We, of course, this is single digit here, this is single digit here. So we are going to check if 4 is at least equal to or greater than 2, which it is. So now we check in what multiplier in the table of 2 gives us 4. So 2 1s are 2 and 2 2s are 4. Very good. We got the exact match. So we write 2 2s are 4. Draw a line again. Do a subtraction. And this time we do these two numbers, 4 minus 4, 0. We just put a cross here. And now there are no more numbers here. That means the number which we were given to divide by 2 is now fully processed. And we have 0 remainder. That means nothing is left. That means this is the answer. So we write here 12 is the answer. Right? So this was an example of a type of division in which we had two steps. We had this step, we had this step. 2 steps or 2 levels of division. Remember that. So when the numbers start increasing their size, then the number of levels of division would increase. Right, let's solve another problem. Oops. And the problem is something divided by 3 now. Let's see. And we take a bigger number. We say 6, 3, 9 divided by 3. Right? So don't be afraid of this number. It looks like 3 digits, but it's very easy to do that. First we write 639 divided by 3, and this is how it's done. We write 6, 3, 9 inside, we write 3 outside. Since this is single digit divisor, we first take the first single digit inside the division sign, and we see if this is greater than or equal to 3. Yes, 6 is greater than 3. So now the only task left for us is to find what multiplier gives us 6 in 3's table. So we check 3 1s are 3, 3 2s are 6. Very good. So 3 2s are 6. Remember this 6. So what we are doing is we are just going to subtract these two numbers here. Just these two. Right. 6 minus 6, nothing left. So the remainder resulted in nothing, and it's the turn of the next digit to fall down. That is how we do it. We bring it down below this line. And now we check if this number is greater than or equal to 3. It is equal to 3, so that means we get it for with the first multiplier, which is 3 1s are 3. So we write 3. 1 times is 3. We draw a line again. We subtract them. This time we subtract these two, right? Very good. So 3 minus 3, nothing left. And now we check if more digits are left, and yes, they are left. 9 is left. Okay, so now it's time for 9 to fall down to this position below. Here. So we bring this 9 to the next level, right? Good. And now we check if this 9 is greater than or equal to 3. It is greater than. So let's see if we can find a number which is in 3's table, which is 3 1s are 3, 3 2s are 6, 3 3s are 9. So we get 3. So we write 3 3s are 9. We draw a line here. We subtract them, right? Just like before, we are going to subtract these two numbers. And we get 9 minus 9 is 0 or nothing left. And now we don't have more digits here, so that means our division operation is complete, and this here is our answer. So we write it as 2 1 3 is the answer, right? Very good. Let's do another question, right? Let's say 81 divided by 3, right? So we write it like so, 81 divided by 3. And how do we do that? We just draw the division symbol, we write 81 inside, we write the divisor outside, which is 3. And then we take the first number, which is single digit. Since the divisor is single digit 3, so we take the first digit 8, sorry, and check if it is greater than or equal to 3. So we see that it is greater than 3. So now we see what is the number which gives us 8 in 3's table. 3 1s are 3, 3 2s are 6, 3 3s are 9. We don't get 8. We get two numbers which are neighbor of 8. One is 6, which is closest, and one is not closest, which is close to 8. And the other number is 3 3s are 9, which is 9 is also close to 8. But we can't use 9, right? The principle says that the number which you get after multiplying with the divisor should be either equal to or less than the number being divided. So that means we can't use 3 3s or 9. Otherwise, let's say if I write 9 here, we can't subtract 9 from 8. Remember, this is not 81 minus 9. We are just dealing with these two digits here. So we can't do that. We need a smaller number. That means we have to use the number before that, which is 3 2 times is 6. And if you notice, it is very important how to write these numbers and where to write them. So the alignment is very important. And you can see the alignment example here and also here. And of course now here as well. So we draw a line here and we do subtraction. 8 minus 6, not 81 minus 6, 8 minus 6. We are just dealing with these two numbers. 8 minus 6 is 2. This was the result of the subtraction operation, and remainder should always be less than the divisor, which is true in this case. 2 is less than 3. That means it's time for the next number to fall down and come and join this guy here. So now it's time for this one to come and be here, right? It is very important to understand this sequence. First we get a we subtract, we got a remainder which was less than the divisor. So it's now the turn for the next number to fall down. Now this number, check this whole number. Is this bigger than the divisor? Is this bigger than 3? It is. So let's check if we can get a number close to 21 by doing the multiples of 3. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, and 3 7s are 21. Okay, so we got it on 7. So we write 3 7s are 21. And then we just subtract them. 21 minus 21, nothing is left, 0. And this is our answer. So we write it like this. We'll say 27 is the answer. Good. Right, now we solve another problem, but first I'm going to align a little bit. I'm going to take all of this, put it a bit below and over here. Good. Because I want to use this in a proper way. Right, let's do another number. And this is going to be a slightly trickier question. And the purpose of this whole thing is to show you how do you handle this. Let's say the number given to you is 200 and no, not 200, 321 divided by 3. How do we solve that? Right, it's a simpler number, relatively simple number, 3 digits, not very big number. So let's do that. 321 divided by 3. There's a very important principle in this, and I want you to really focus here. So we do the regular way of doing 321 inside and 3 outside. Right, so let's start dividing. We check the number of digits of the divisor, which is single digit 3, and we take the first digit here and check if it is equivalent or it is greater than or equal to the divisor. So 3 is equal to 3. That means the first division is easy. 3 1s are 3. Notice the alignment. 3 1s are 3. We subtract this and we get 3 minus 3, nothing. So the result of subtraction operation resulted in 0 or nothing. It's time for the next digit to fall down. Notice. So we bring down the next digit here, which is 2. So we check, can we divide this 2 by 3? There is no way. So this division is not possible to this point. We need a bigger number, and we do have another number waiting for us, right? But we can't just simply bring it down to make it 21. There's a rule here. If we don't have enough sufficiently large number at this step, then we can bring this down, but first we must put a 0 here. Only then we are allowed to bring this 1 here. And now this has become 21. This is greater than 3, of course. So let's check if we get 21 in the table of 3, which is 3 1s are, let's make it short, 3 5s are 15, 3 6s are 18, and 3 7s are 21. So we write 7 times 3 7s times 7 times is 21. We do regular subtraction. 21 minus 21, nothing is left. And this is our answer, which is 107. And notice this time we have not eliminated this 0 here. We have not removed this because this is sandwiched inside the number. There are some non-zero numbers left and right to this 0. So this 0 cannot be removed. Only the leading 0 can be removed. This is not a leading 0, it's somewhere in the middle of a number. So this answer is 107. And you can always reverse check, you know. You can always double check your answer. So let's say you want to verify whether you got the correct answer or not, right? So what you do is just simply reverse the process, and I'm going to do it here. So this is now multiplication, right? What you do is you take the answer 107 and you multiply it by the divisor which was here. You multiply it by that number, and then you do this calculation. 3 7s are 21, 2 here. 3 zeros are 0, plus 2 is 2, and 3 1s are 3. Did we get the same answer which we had in the beginning? Yes, we have. We got the same answer. These two numbers are same. So that means this 107 is correct. And this was important for you to notice that when a number, when a number is smaller and we need to bring down yet another number out of its turn, then we first put a 0 here. And it's always going to be a 0, no other number. We put a 0 here and then we bring down the next number and join it with the existing number, make it larger, and then we do the division. Now, let's solve another number, right? We don't have much space here, so I'm going to add a page. Let's solve another number to highlight this problem of zeros. So let's say you have a number which is 206. Very easy. Okay, let's solve it simply. 206 divided by 2, right? Let's see. What do? We write 206 divided by 2. So what do? Is we make this symbol 206. Remember, your 6 and zeros should be identifiable and differentiable. Your 0 should not look like 6 and your 6 should not look like a 0. 206 divided by 2. Okay, so we check first 2 digits and they are equal, so that means we can always get it in the first time, which is 2 1s are 2. Notice the alignment. Notice what I am subtracting. I'm just subtracting this 2 from this 2. So 2 minus 2 is 0 or nothing left. Now it's the turn for this next digit to just fall down. So it's going to fall down here. And we write 0. And now it's turn to get divided, but we can't divide 0 by 2. This is not enough. This is smaller than 2. The rule says it should be equivalent or greater than the divisor, and this is actually smaller. Even though 0 can be divided by any number, 2 zeros are 0, 3 zeros are 0, 4 zeros are 0, 1 million multiplied by 0 is 0. But that's not the point here. The point is the rule says this number should be equivalent or greater than the divisor, which it's not. So, and it has already completed its turn. It has failed to satisfy the condition. That means we should check if we have more digits here, and we have. But then we need to bring it down out of its turn. That means we can do it right here. But to be able to do that, we are only allowed to do that if we put a 0 here in the quotient section or the answer section first, and then we bring this down here, right? So now we have 6 here. It is not 60, of course, it is just 6. And we could not write this 0 as a cross because we have brought it down from here. So this is required. It is read as 6. And let's see, let's check 2's table. So 2 1's are 2, 2 2's are 4, 2 3's are 6. Very good. So what we can do is we can say 2 3's are 6. And we subtract it. 6 minus 6 is nothing, and this was just 0, so it doesn't matter. And this is remainder, which is 0, and we have completed all our numbers or digits here. So this is our answer. So this means 103 is our answer, right? So this was important. You must understand the principle behind bringing down another number out of its turn. When it is its turn, then it's no problem. When the numbers are bigger enough to be divided, then it's okay. Let me give you an example where it's not going to be a problem at all. Okay, so let's divide 246. Forgive me, this is a horrible 4. 246 divided by 2. Very easy. It's like butter. So let's write it first. 246 divided by 2. And then we draw the symbol. We write 246, and then we write 2 here. Let's divide this number. Super easy. This is single digit, so we get the first digit here and check if it is greater than or equal to the divisor, which it is. So 2 1 times is 2. Notice the alignment. Notice what am I subtracting? I'm just subtracting 2 minus 2, which gives us 0 or nothing. Right. So now it's the turn of the next number to fall down. Very good. So it falls down here, which is its turn. So we don't need to put an extra 0 anywhere. Right. So this is 4. And this is, again we check if it is greater than or equal to the divisor. It is true, it is greater than 2. So let's see, 2 1's are 2 and 2 2's are 4. Okay, so it's divisible. We write 2 2's are 4. We subtract it and we get 4 minus 4, 0 or nothing. Okay, good. Now it's the turn of the next number to fall down. We bring it down in its own column or correctly aligned. 6. And we check if this is greater than or equivalent to 2. It is greater than. Then we check which multiple is closest to 6 in 2's table. So 2 1s are 2, 2 2s are 4, 2 3s are 6. We get a complete match. 2 3s are 6. Draw a line, subtract 6 minus 6, nothing left. Very good. So we processed all the digits. The complete number is fully processed. We got no remainder, and this is our answer. So we write 123 is the answer. Very good. Nice. So this was what I wanted to show you. Now I'm going to show you some simpler examples of other type of examples. They are very easy. I want to show you that if the number ends, if the dividend or the number being divided ends with a 0 and the rest of the numbers are fully divided, then what to do with that 0? There are special cases, so I'm going to show you those cases. They are super easy. Let's say you divide 50 by 2, right? Now this is a pretext to that problem, so this is not going to show you what to do with that 0 because it's going to be processed differently, but this is an example. It's an important example, and it's required to build the base. So we say 50 divided by 2, and we do this 50 inside, 2 outside. We check this is single digit, we take the first digit which is greater than 2, so that means it's somewhere in 2's table, so we find it. 2 2s are 4 and 2 3s are 6, so it doesn't fall in 2's table, but the closest number which is less than this number is 4, so we say 2 2s are 4. We subtract them, we get 1 as remainder, and now it's the turn of this 0 to come down. It is its turn, so we don't need to put an extra 0 in the quotient above. Now it becomes 10, and 10 comes in 2's table with the multiplier of 5, so 2 5s are 10, and we subtract them and we get nothing left. So this is our answer, which is 25. This is the base of the problem. The problem I'm trying to show you comes now. 50 divided by 5. This is the problem. What happens now? So we write it as 50 divided by 5. We do that, 50 inside, 5 outside, right? Same principle. Single digit, we check, we pick up the single digit from inside, we compare. This number inside is greater than, or is it greater than or equal to the divisor? Well, it is at least equal to the divisor, so 5 1s are 5. We subtract them, this column only, we get nothing left. And now this 0 falls down to its place because it's now its turn to be divided. Right. After falling down, we see this is not enough. This is not greater than or equal to 5. So we need another number, right? But that's the problem. We do not have any number here. We don't have anything here. That 0 was the last digit. So what do? Well, the rule says that in such a case, what you simply do is you don't need to bring it down because that was the last digit. You just put it here and that's it. That is your answer. This is your answer. You don't bother bringing it down here. So this means 10 is the answer of what you did. And I can verify that this is the correct answer by doing a multiplication. So we reverse the operation. We say, okay, we have a 10 here. We multiply it by what was the divisor earlier. So 5 zeros are 0 and 5 ones is 5. So we do get our number back. So that means our operation is correct. And this is the type of question I wanted to show you also. Now let's remove this one because I don't need this. Okay, let's do another number. Let's do 500 divided by 5. Right, so this is basically building on the same principle. What do? We first learn that this is 500 divided by 5, and by practice you would just simply be doing it in your head. 500 divided by 5. Okay, we make the division sign, we write 500 inside because it's being divided, and divided by 5, we write it outside. Now we start our division operation. This is single digits, so we pick a single digit, the first digit from inside, check if it is greater than or equal to the divisor, and it is equal to the divisor, which is okay. So that means we can get it in our first attempt. 5 ones are 5. So we subtract 5 minus 5, nothing left. Now it's the turn of the next 0 to come down, right? But we can see visually that we have this 0, we have this 0, and then we have nothing left. We have nothing left here. We just have 2 zeros left. So even if we bring them down, it's not going to be of any use. So the rule says that in this case, you simply take these remaining zeros and bring them here. So that is what I'm going to do. I'm going to just bring the remaining zeros here, and that is my answer. This is a very important tip, and it's very, very simple. It saves you a lot of time. So I can say that my answer to this operation is 100. And I can verify that by reverse multiplying it. I can say, well, my answer was 100, so let's write 100. And my divisor was 5, so let's multiply this answer by 5 and see if I get my number back. 5 zeros are 0, 5 zeros are 0, 5 ones are 5. I did get my number back. So that means my operation was correct. And this, my dear students, is how you do division, right? And this was the tip with the zeros at the end. Only if the number before the zeros is finally divided. I can give you one last example in which I'm dividing 100 by 2, right? What do? It is 100 divided by 2, so I'll just write 100 inside and 2 outside. Now remember, there are 2 zeros here. I can't simply bring 2 zeros in the answer because I still need to divide this one, and this is not fully divisible by 2. That means I'm going to use these two instead and say 2 5s are 10, subtract them. So 10 minus 10 is nothing left. Now I am left with this single 0, and there is nothing in front ahead of it as well, no trailing digits. So what do? Now I follow that rule that when the zeros are left, only zeros, and no more division is possible, then you simply bring them up here. So I just add this 1 0, because the other 0 was already used by the number 10 to make it the number 10. And I can verify that. First of all, let me write my answer is 50, and I can reverse check by doing my answer multiplied by my divisor, which was this one. So 2 zeros are 0, 2 5s are 10, this 10, and I get my number back. Good. Let's do one more question before I leave. Let's do divide 1000 by 2. What happens now? So we write 1000 inside, 3 zeros, and 2 here. So this is single digit. We pick single digit here, but the number we picked is smaller than 2. It should be at least equal to or greater than 2. That means I need another number from the right to join it. Right? This is what I do to join. So now this number is 10. So I'm going to do 2 5s are 10. I'm going to subtract them, draw a line, 10 minus 10, nothing left. And now I have these two zeros. And I can see that I have no other number here on the right, right? Nothing here. So the rule says if you are left with just zeros, only and only zeros, nothing in between, no other number, and you just simply bring them up here, like so, and this becomes your answer. So I can write 500 as my answer, and I can verify that for you. I can multiply the answer by the divisor which we had, which was 2, and see if I get my number back. 2 zeros, 2 multiplied by this 0 is 0, 2 multiplied by this 0 is 0, and 2 multiplied by this 5 is 10. 2 5s are 10, and this is that 10, 1 and 1 0, 10. And I do get 1000 back. I do get my number back. So my operation was correct. Right, so this is how you do basic division, level by level. And I also showed you what to do with the numbers when you have zeros left and no more division is possible. Right, thank you very much for your time. I hope you learned something today. Right, so we'll meet in some other video, maybe 2 digits division with double digit divisors, and we'll see how to do that, maybe, if I get time. But if you do this one, and I really encourage you to do, at least 20 to 50 questions, just random divisions. Ask somebody in your family or in your friends to give you like 20 to 50 numbers, simple numbers, and then just divide them. Very, very easy. Right. Thank you very much for your time. Assalamu alaikum.